Hello, civil engineers. Welcome back to the lecture. So once we have completed the column bar bending schedule, the next part what we have is a beam bar bending schedule. So beam BBS should be done something like this, which I'm going to explain you. It's very simple, but the thing is, it's a bit tedious method. That's it. But the concept remains the same. Now, what I'm going to do is see. This is a drawing what we had, isn't it? It was a G+2 building where I had explained you the column part and also the footing part. Now coming to the beam part, so these are the beam reinforcement what they have given. Okay, like they have written GB1 and they have given the size of the beam, and then the reinforcement has been given. Okay, like where the straight bar will come, where the extra bar will come, and these are the stirrups what they have given. But with this particular drawing, it is not possible for us to do the bar bending schedule. It's not that it's impossible, but since I'm teaching you, it is easy for me to do, but for you it will be a bit difficult to do the BBS of this since you don't have the longitudinal view of this. Okay, what do I mean by longitudinal view? I'll explain you. This is one drawing what we have. I'll take you to one more drawing. So this is one more drawing what I have. So here, this is one of the assignment what I had given. So here they have given a beam which is 300 by 400. And for this, what they have mentioned, they have given the longitudinal view. So this is called as longitudinal view. That means here in a complete one stretch, you can see what are the different diameters of the bar that you're supposed to use, what is the extra bar that you're supposed to use. You get the bottom reinforcement. So if you're not able to understand, I'll draw it in this way. Okay, yeah, see, this is one bar, this is your top bar. Okay, this is your top bar. Then comes your bottom bar, you can see here. So here comes your bottom bar, this one. Okay, here comes your bottom bar. Then you get a top left extra. Then what is that? You get a top left extra, something like this. You can see this one bar here, this is my top left extra. Then I get my top right extra, this is my top right extra bar. And then I get the middle straight bar. So this is a middle straight bar, right? Appreciate it. And what are the different diameters, everything is mentioned here. And the stirrup is also mentioned. You're supposed to provide the stirrup here, S1 and S1, which at a span of 800 and 800, and which diameter, which two leg stirrup, it is mentioned here. See here. So if I scroll down, no, it is mentioned. S1 is 8 die at 100 center to center spacing. S1 means what is that? This is S1 for me. This is S1 and this is S1. Here you are supposed to keep, and in the center you are increasing the spacing of 150, right? And along with that, you get a cross section of this. What is the cross section? Cross section is something like this. So this is a cross section of the. If I cut a beam and if I see from here, I'll get to know like I need to provide 20 diameter. I mean 25 diameter 2 bar at the top. This is 125. This is another 25 at the corner, and in the middle I'm supposed to provide 20 diameter 2 bar. Similarly, in the bottom, I'm supposed to provide a 20 diameter 2 bar. This is 20 diameter 1. This is 20 diameter another. And in the center, I'm supposed to provide a 16 diameter 2 bar, right? So this is a cross section what we get. It is written section. And this is a longitudinal view. And this is a longitudinal view what we get. But whereas the drawing, the AutoCAD drawing, what we were looking, this particular thing, yeah. Can you tell me whether all the same things are given in the drawing? No, there is no longitudinal view given. There is no cross section given, but they have given something in the form of a table. So since we are doing it for the first time, it will be very difficult for me to teach you all these things. So what I'm going to do, I'll take this particular project because I had given you because this is the same project. It's a G+5 story building. Yeah, it's a G+5 story building where I had given you a lot of assignments to be done. Okay, so for the same building, I'll teach you how the beam BBS has to be done. This entire thing, plinth beam layout, I'm going to teach you for the complete this. I'm going to teach you each and everything in this. Okay, and once we understand this, then it will be easy for me and for you also to understand this particular drawing. Otherwise, it's quite difficult at the initial stage. In the same way, I'll show you one more drawing. This is one more drawing what I have. See, again, it's a one of the school building where we had taken the irregular foundation. So it's a second floor slab and beam layout they have given. And for this, you see, they have given something like this. This is what we want. If you want to do the bar bending schedule, you need to have a kind of a longitudinal section, something like this, where you can understand that you're providing a 16 diameter 2 bar at the top, you're providing a 16 diameter 2 bar in the bottom, then you're providing an extra bar which is a 20 diameter 2. EXT means extra from on the left support, and even on the right support you have a 20 diameter 2 bar extra, and then you have a bottom curtailment which is a 16 diameter 2. So and then you get a stirrup which is mentioned 2 leg stirrup 8 mm at 150 center to center in the left space, and even on the right also it is same, and in the your middle span it is 200 center to center. So if you have a cross section something like this, we can do the BBS, but unfortunately, like I mentioned, it is not mentioned here. So what I'll do, I'll start with this now. I'll start with this project, and once I teach you this entire project, you will be 100% ready to prepare the Excel sheet like this. And once you prepare an Excel sheet in this way, once you learn this, then I'll come back to these 2 drawings as an assignment. I'll come back and teach you the BBS for this building, not completely. 1 or 2 beam I'll teach the complicated part, and also I'll come and teach you this particular part also, so that 90% of your basics will be strong here, and few things I'll explain you what is this 1 and 2 written here and how to read the drawing. Is it clear? So now we'll start with this particular project. So this is the same drawing what I've uploaded. So you can download the drawing. If you have downloaded, check this particular drawing, design of G+5 mixed use building. Okay. And now come to the plinth beam part. So it is a plinth beam part written here. Okay. So this is a plinth beam layout given. So I will start with the BBS of this particular beam. So it's written here. Okay. Like the beam size is 300 by 400, 300 by 400, and all these are the grid line. A, B, C, D are the vertical grid line. 1, 2, 3 are the horizontal grid lines, and the size of the beam is given. So we are not concerned with this. We are concerned with the steel. So now you just observe. First, I'll start with this. Okay. First, I'll start with this. Yeah. So first, I'll take this particular beam. Only this particular beam. Okay. This particular beam. Yeah. This is a beam I'm concerned with. I'll find the BBS for this. So for the same beam, you have to understand A, B, and C, and this is A grade. For this beam, what is the reinforcement that is mentioned here? So you can see this part you need to concentrate now. This part. Okay. Yeah. So this is that part up to here. Okay. This is that part. And then don't concentrate on this part. Not required, and don't concentrate even in the bottom part. Okay. Now this is a reinforcement what is given. So you know how to read all these drawings. So in the drawing reading course I've explained you, but still here I'll explain you. See, first thing, note down all these things. Whenever you're finding the BBS for the beam, you need to understand few things. There are few concepts which you need to understand. Always remember, take a note of this. First you need to find, yeah, first you have to find the bottom main bar. Write it down. First you have to find bottom main bar, and I'll show you simultaneously what is bottom main bar. So this is my bottom main. See, for someone who doesn't know that I'm teaching this, for someone who knows that, you can forward my lecture and you can go forward. Okay. If you find I'm repeating the same thing, just in case if you know, then you can forward it. Okay. This will be my bottom main bar. Got it? Fine. This much is clear. Now for this, I'll show you the practical image also. So practical image. Yeah. Okay, then I need, okay, I'll delete everything. Okay, it will take some time for me to teach you all these things. Yeah. Now this is a beam what I have. So tell me which is my bottom main bar. So this is okay. I'll start with this only. Because if you can imagine these things, then your BBS will be simple. But if you can't imagine, it's difficult. Okay. Yeah. So this is my bottom main bar. You can see the bottom bar. This is bottom main bar. Okay. Wait, even this drawing is not good. I'll take a good drawing now. Okay, I'll go with this only, no issues. Okay, this is my bottom. Okay, you can see in the bottom I've given a bar. So this is bottom main bar. So here there is 2 number of bar. Let us consider in the drawing, in the live structure. In the drawing also, if it is 3, then practically we'll be putting 3. This much is clear. So this is bottom main bar. Similarly, I'll show you one more image so we can check this particular drawing. Yeah. Again, if you tell me, if I consider this particular beam, if I consider this particular beam, tell me what is my bottom main bar exactly. This is my bottom main bar. Okay, this is the first thing which you need to understand. Yeah. So after that, once the bottom main bar is done, next what we are supposed to do? Next, yeah, once the bottom main bar is done, next we say the second point. Second is top main bar. What is that? Top main bar. Okay. So which is your top main bar exactly? This is my top main bar. So this is your development length up to here. It will be a development length. From here, your bar will go straight, and then it will get something like this. Okay. So this is my top main bar. This is my second bar. So practically, if I want to show, of course, I'll delete it. And this is my practical image for that. So this is my top main bar, which has come like this. You can see the bar here. This is one bar, and this is second bar, what is given here. This is top main bar. Bottom, I've explained you. If I want to show it on a different drawing again, yeah. So this will be my top main bar. Okay. So you can see a bar has, they have given a L here, and the bar has been taken. It's a continuous span, doesn't matter. Bar has come and it will get a L in this way. Okay. If I'm giving 2 bar, it will be like this. Understood? Fine. Great. So 2 are done. Next we'll go back. Then we have something called as the third bar, which we usually get. This 2 bar at any cost you are going to get. Bottom main, top main. Okay. Then the third one. The third one, what we get is top left extra. Remember this, top left extra. So what is this top left extra? So you can see a kind of a bar here. So if I take a different color, you can see here, you can see a small dash given. See, since you're seeing it from the front, you cannot see this bar, because this bar, this top left bar will be inside the top main bar. So, but still you can identify here, no, the small thing. Yeah. So this will be your top left extra bar. Okay. This will be a top left extra. And similarly, this, I'll write one more bar also simultaneously. I'll show you that. The fourth one, what we get is a top right extra. So why I'm telling right? Because it is on the right side for me. Top right extra. Okay. So this is my top right extra. Yeah. You can see this bar. So it will come and it will get L here. And same, this also will get a L here. Got it? So top left extra, top right extra. Total 4 bars I have shown you. So practically, I'll show you all those 4 bars now. So if you come here, you can see a kind of a bar here. This is already a main bar. Okay. The top bar, what you can see. Okay. Okay. Fine. No problem. I'll teach. You can see this bar here. Okay. Same. This is top left extra. And you can see here, this is your top right extra. Got it? So, but this top left extra, top right extra, it won't be there in all the beam. It depends on the load coming on the beam. It depends on the bending moment. If you have more bending moment and if your main bar is not sufficient to take care of that steel, then you provide additional steel. Huh? Got it? So similarly, if you want, you can see here. Look at this particular beam. Do you have any top left extra? Do you have any extra bar here? No, you don't have, because here your top main bar is sufficient to take care of the negative bending moment. So you don't have to provide the bar. So these things will be decided by the structural engineer. Again, if you see here, see your top main bar, your bottom main bar. You don't have any extra bar here. But if you observe here, in this particular beam, you can see an extra bar here. See, this is your top left extra. But on the right side, it has gone inside here. Maybe there may be 1 bar somewhere here. Okay, totally depends on the beam you are going to design. But you understand the concept, how the BBS has to be done. Similarly, if I show you one more, here also it's not there. Top 2 bar, bottom 2 bar, no left extra, no right extra. Okay. So I think all the cases I have taken now. Yeah. Similarly here, of course. Yeah. Similarly here also you don't have it, but you understood the concept. Fine. So these are the 4 bars that you usually get. And when we do the BBS, we need to understand this. So top, and then after that, there will be one more bar. There will be one more bar. That will be 5th one. Okay, which is middle straight bar. What do you call that? Middle straight, STRAIJ, middle straight bar. So what is that middle straight bar? Very simple. You see here, this is a column what I have. Okay, you need to understand. Yeah, this is one column. This is column number 2. It's a continuous beam. You have 3 columns, and this is a continuous beam. Now again, you see here, there is a beam. You can see, I'll show it here. We'll go with a different color. I'll go with yellow color. You can see a kind of a bar here. So this is your middle straight bar. So it will be something like this. I'll make it thick. It will go like this, straight. It will be going. Okay. So it will be going straight. Got it? This much is clear for you. Middle straight bar. Practically, if you ask me how show this bar practically to me. See, right now it is not here. Practically here also not possible. I'll show you one image. Okay, and here also it's not possible. So if you ask me practically, I'll tell you. Right now they are not put, but they are going to usually put. See, this is one column for me. Okay, this is my second column. This is second column, and this is third column on the right side. Consider this is a column. Else I'll do in this way. This is one column. first column, this is second column, and you have another column here. Okay, 3 column. So in according to our drawing, we'll have a top straight bar. So it will be something like this. This is the column, no? This is main bar. In between the main bar, next to the main bar, we'll be providing a bar something like this. So this will be your top middle bar. Is it clear? Right now, I don't have an exact image for that. In case if I get, I'll show you in the next lecture. Right now, I hope you have understood. Okay. Now, quickly, I'll explain you the concept behind this, why this bar has to be given. Actually, being a BBS engineer or being a engineer, you don't have to know that. But since you have taken the courses from me, obviously, I'll be teaching you those things. The reason is very simple. Many of you know if you have taken my basic course, but quickly, I'll give a idea regarding what it is all about. Okay, usually what happens is you have a column and column. You get a kind of a negative bending moment, then you get a sagging bending moment, then you get a negative bending moment, then you get a sagging, and you get a negative. Okay, so if I draw a line here, if I draw a line here, if I draw a line somewhere here, okay, so whatever I'll go with a different color. I'll go with magenta color. Yeah, so this is a middle line. So whatever you have on the top, it is a negative bending moment. So it's a negative bending moment. It's a negative bending moment. And whatever you have in the bottom, this is sagging bending moment. This is sagging. That means in this position, beam is trying to go down, go down. And this indicates your beam is trying to hog in this way. Okay. So wherever your beam is trying to hog, we need to provide top steel. So that is why you can see top left extra has come here, because here we have negative bending moment. Similarly, here also we have negative bending moment. So we have given a top left right extra. In the middle, it's a continuous support. So whenever you have a continuous support, due to the joint, or due to the junction between the beam and a column, what will happen? Your beam will try to go up at this junction. When the load comes, your beam will try to go up. The moment it goes up, it requires a top steel. So that is why we are providing a top continuous steel here. That is a top continuous bar. Got the concept? Same thing is here only. Practically, if you ask me, sir, how does it look practically? This is how it looks in practical. Okay. So this is a column and a beam. You get a negative bending moment, you get a positive bending moment, you get a negative, and you get a negative over here. So this particular area at this junction, because for this column you have a beam here, we have a beam here. So this particular beam will try to lift up. So whenever it tries to lift up, we need to stop that. So we provide a top straight bar here. Same is the case here. Here also the beam will try to lift up. In order to avoid that, we provide a top left extra. Similarly, here also a beam is going to try to lift up. So we provide your top right extra. That is a concept. And if you want to know how the steel and all are designed, that is taught in my site engineer course, that is taught in my ATAP course, and all my courses. I've explained you how the steels are designed and all. Since we are doing BBS, we don't require that. Good. So this much is understood. So once you understand this, the next part is very simple. Next, what they have mentioned, next we'll try to understand the this thing. What is that? Diameter here. Okay. So what is this 25 dia 2? It is indicating this. Okay, we'll start from the bottom now. So bottom, they have written, you have to provide a 20 diameter 2 bar, this part, and 16 diameter 2 bar. Good. They mentioned 20 diameter 2 bar and 16 dia 2 bar. Similarly, here they have mentioned 20 diameter. Okay, anyhow, I'll go back with this. Yeah. So we'll keep this drawing back. Okay, fine. Now we'll go with this. Yeah. So what is written here? So they have written 20 diameter 2 bar and 16 diameter 2 bar in this particular beam, and also 20 diameter 2 bar and 16 diameter 2 bar. So it indicates that you can see the bottom steel, that is a green color. There you are supposed to provide a 20 diameter 2 bar, and also you are supposed to provide a 16 diameter 2 bar. I'll do one more thing. I'll just delete this part. I'll put a cross section of that, so that I'll explain you only for one beam. After that, I won't be explaining anything, okay? Because since it's the first lecture, let us understand everything. And I'll bring it here. Okay, wait. So what I can do is, give me a minute. Yeah, now it should be all right. Okay, fine. Now I explain you these things. Okay, this has gone down. Yeah, no problem. See, this 20 diameter 2 bar is bottom, and in between this 2 bar, your 16 diameter 2 bar will come. Okay, simple. So from here to here, everywhere it is the same thing. Understood? Then that means whenever I find the cutting length of my bottom bar, I need to find it for 20 diameter 2 bar and 16 diameter 2 bar separately. So practically, if you want to see, I'll show that in Excel sheet. So in the Excel sheet, I've done it. See here, okay? See, this is for 20 diameter, one time I've done, 16 diameter, one time I've done. Good. After that, next is top. You come to the top now. Top, they have written 25 diameter 2 bar here, 25 diameter 2 bar. That means the one orange color bar you can see. So this is my 25 diameter 2 bar, which will go throughout. Like in bottom, we had 20 diameter 2 and 16 diameter 2 going throughout. In the top main bar, it's a 25 diameter 2 bar going throughout. So practically, if you want to see, or in the BBS, what we'll do, this is my top main bar, which is 25 diameter, which will go throughout in this way. Okay, got it? Great. Now, once this is done, next what we are supposed to do, next is my top left extra. So my top left extra is this blue color. So what is written here, 25 dia 2 plus 20 dia 2. It means already 25 diameter 2 bar you are completely put. Along with that, only in the left junction, you're supposed to provide a 20 diameter 2 bar. So this is my 20 diameter 2 bar, which will go only up to 1670 from the face of this column. I mean, from the inner side of the column. So practically, if you want to say, it will be something like this. See, this is that. Okay, what I've written, top left extra, I mean this one. Yeah, this one. Yeah, top left extra, only this part. Okay, got it? Fine, great. After that, what is left out? Tell me. After that, we have a top right extra. So this becomes my top right extra, which will extend from 1550 from the inner face of your column. Okay, this is my top right extra. What is the diameter? It is actually a 20 diameter 2 bar, because already 25 of 2 is gone completely. Along with that, in between that, you need to provide a 20 diameter 2 bar. So practically how it looks, this is how it looks. I mean, when you do the Excel sheet, so this is my top right extra. So top right extra. So this is my another bar. And the last what we have is exactly the last one what we have is a middle straight bar. So this is my middle straight bar, that is a yellow color, which is again a 25 diameter 2 and 25 diameter 2 means already it has gone. In between that, you're supposed to provide a 20 diameter 2 bar and 20 diameter 2 bar. So again, if you ask me on the Excel sheet how you do, this is how it goes. This will be my straight bar at B junction, which is a 20 diameter 2 bar. Got it? After this also, if you still have doubt, you can get back to me anytime. So if you want to see the cross section of this, it is mentioned here. So now you will get an idea how it looks practically. See, this is one cross section. We had 25 diameter 2 bar, which will go completely. So this is a 25 diameter 2 bar. So 20 on the top, I'm speaking first. Okay. So top 25 diameter 1 bar, top 25 diameter another bar, 2 bar. Okay. In the same way, in between this 2 bar, we will have a 20 diameter 2 bar. So this is my 20 diameter 2 bar, 1 bar, this one, second one. So where this bar will go? Top left extra and top right extra, and middle straight portion it will go. Okay, good. Next, come to the bottom portion. In the bottom, we are supposed to provide a 20 diameter 2 bar and 16 diameter 2 bar. So this will be my 20 diameter 2 bar. So this outer one, 20 diameter 1 bar, 20 diameter 2 bar. And then the middle one what we have is the 16 diameter 1 bar, 16 diameter 2 bar. So this will go completely throughout the length. So first your 20 diameter 2 bar will be outside, and inside will be your 16 diameter 2 bar. So all 4 bar will be in the same line, but outer 2 bar will be, this is outer 2 bar will be your 20 diameter, and inner 2 bar will be your 16 diameter. Simple. Got it? Yeah. So other than that, if you still have doubts, you can get back to me if you're not able to imagine this, but to the fullest of my knowledge and the way I can explain, I've explained you all these things. Okay. So once you understand this, now we have understood how the bars are placed. Along with that, the stirrup part, you know. Okay. I think stirrup I didn't take, but stirrup is simple. These are the stirrup part. So these are the stirrup. Okay. Stirrup on the left support. This stirrup is on the right support up to here. And in your middle also you're supposed to provide the stirrup, but in the middle the spacing is different. Like I mentioned, this spacing is 100 mm. This is 100 mm spacing. This is also 100 mm spacing. In the middle, your spacing is S2. That means it is 150. Okay, that is written in the drawing. I already shown you. So practically, if you ask me how it looks, practical, these are your stirrups. Okay, this is how it is. So this will be at 100 mm center to center spacing, this stirrup on the left side up to here. And also on the right side, it is 100 mm center to center. Okay. And 100 mm center to center, and in the middle portion you can see the distance has been increased. So this is your middle portion. Let us say this is your middle portion. Okay, here the spacing is 150, 150, 150, 150, 150, 150. If I want this, I can make yellow color. This is 100, 100 up to here. Until what distance it has to go? From here to here. Till what distance it is 100 mm? From here to here, at what distance it is 100 mm? It is already mentioned. If I remove this, it is up to 800 from the face of the column, up to 800 from the face of the column, and whatever is left, that will be a center portion. Okay, this much is understood. This much you can understand. Fine. Now again, for the bending moment, I will explain you the concept. Again, I'll explain you why these shear forces are kept near the support, why the stirrup is very less, why the spacing is less. At the center, why? Because near the support, your shear force will be maximum. If your shear force is maximum, more steel is required. So more steel can be provided by closely spacing. So that is why near the support, that is this support and this support, your shear force is maximum. Whereas in the center, your shear force is less compared to the support. In the middle, your shear force is less. If your shear force is less amount of steel is required. If less amount of steel can be provided by increasing the spacing. That is why in the middle we increase the spacing. So if you ask me how the shear force diagram looks for this, so here your shear force will be maximum. Okay, this is my support. This is also my another support. Here the shear force will be maximum. Okay, and how shall I do this? Yeah, it will be maximum. And wait, let me do in this way. Okay, I'll go with this. Okay, let us say if this is my center of the beam, and this way. So here my shear, this is my maximum shear force. Here the shear force will be maximum. And here you have done all these things in your structure analysis classes. Shear force is maximum, and here we try to do in this way, right? So can you see this particular zone, that is a middle zone? Where is the middle zone? Yeah, this particular zone. So this is my middle zone. So can you say, can you check here? Here your shear force is coming down. No, this is maximum. Let us say it is 100. This is also 100. From 100, it is varying, no? From 100, it will come to 90, 80, 70, 60, 50, 40, 30, 20. So this point means it is 0. Again, minus 10, minus 20, minus 30. That means at this particular junction, your shear force is less. If your shear force is less, less steel is required. And since we are providing a stirrup here, if you increase the number of spacing, your shear reinforcement will come down. I mean, number of stirrup will come down. That means area of steel is less. But here we are increasing the spacing because shear force is maximum. Maximum shear force means more steel is required. More steel can be provided by spacing, by reducing the spacing. This is the concept. Many people tell that since negative bending moment is maximum here, we provide the stirrup at very close spacing. That is not a technical answer. Those people don't know anything. Okay, fine. There is one more reason to that. The one more reason is if you refer Indian Standard Code book. I mean, if you are putting your structure in the earthquake zone, in that case also, what we need to do is we need to provide the spacing very closely near the support. We are supposed to keep the spacing very closely near the support, and in the center, if you want, you can keep the same thing, else you can increase the spacing. Again, what is the reason for this? Because during the earthquake, see, you don't know how your earthquake can come in this direction, your earthquake can come in this direction. Okay, so this is the junctions what we have. This is a beam and a column junction. So this is a beam and a column junction. Okay, so here what will happen, these are the point where the plastic hinges will be formed. These are the places where the plastic hinges will be formed, where it will experience maximum shear force, and these are the places where your plastic hinges will be formed. So I don't want to make this particular joint, that is a beam column junction joint, a brittle failure. I mean, when I say brittle, suddenly it's going to fail. So suddenly I don't want that junction to be failed. So that is the reason what we do. We provide more reinforcement near the beam column junction and beam column junction. So this is according to the earthquake theory. Okay, so that is why, again, for the same reason, we provide it in this way. Got it? Everything I've explained you. I've explained you the complete drawing, how it has to be read and all. So in the next lecture, we'll directly get into the BBS part of this, and I'll explain you. Again, I won't explain to the level I'm explained now, like top bar, bottom bar, and all. No, you watch my lecture. If you're not understood, watch it once again, and after that, we'll start with the BBS of this particular thing. Okay, so we'll see you back in the next lecture. Thank you.